So up next is solving with substitution. You guys saw before that graphing is not always the most accurate thing in the world. So we have two ways algebraically to do this. And the first one is substitution. So substitution is something we've been doing for a while. I've been giving you stuff like 3x plus 2 and then telling you that x is 10. And you know to plug in x and figure out that this is 32. What you did right there was substitution. You took a value for x and you substituted it where you saw x. So we're going to do that now, but instead of with numbers, we're going to do it with expressions. So if we look at this first example right here, I'm told that y is the same thing as 3x, and then also 2x plus y equals 45. So what I'm going to do is take what y equals this 3x here, and I'm going to plug it in for y. I'm going to substitute it in there. So everything else stays exactly the same. The 2x, the plus sign, but now instead of writing y, I'm going to write what y equals. And y equals 3x. And then everything else stays exactly the same. There's still an equals 45. Now what happens when we do this is we end up with only one variable now. If you look, this new thing that we wrote only has x's. And we know how to solve things that only have x's. So we can combine our like terms here. We'll end up with 5x equals 45. And then if we divide both sides by 5, we get that x equals 9. This is an answer, but it's not the whole answer. Think back to the graphing. We needed a point when we were solving things. We needed an x value and a y value. All we've found right now is an x value. So to find our y value, we do substitution all over again. Now I know what x equals, so it's more like this problem up here. You're going to take that x and you can plug it into either equation. It doesn't matter which one. This one's easier, so that's the one I'm going to substitute it in for. This tells me that y equals 3 times whatever x is. In this case, I found that x was 9. So if I multiply these together, I end up with y being 27. And now to turn this into an answer, we want to write it just like we wrote the answer to the graph. You put it in an ordered pair. 9, 27 is the answer to this system. If we were to graph those two equations, that's where they would cross. So we always start with an easy one. They're going to get a little harder, but not much. If you look at the next one, there's not an equation that has a variable by itself. Like the last one said y equals something. For this one, that didn't happen. But we can make one of these things equal some stuff. So as I look at both of these equations, the very first equation has x kind of by itself. It's just a plain old x. So that would be very easy for me to get by itself. All I would have to do is subtract 4y from both sides, and I would end up with x is the same thing as 1 minus 4y. Now that I know what x equals, I can take that, and I can replace it in the other equation wherever I see x. That should circle the x, and it's not. So, I'm going to come back up here. Everything stays the same except for what I substituted. So the 2 stays the same, but now instead of writing x, I'm going to write what x equals. 1 minus 4y, and then minus 3y equals a negative 9. And again, I'm left with just one variable. It's still messy, but we can solve this. We want to get y by itself. So right now there's some parentheses that we have to undo. So I'm going to distribute this 2. And I get 2 minus 8y, and then still minus 3y. equals a negative 9. Still some more simplifying to do. So I want to do negative 8 minus 3 more gives me negative 11 equals negative 9. And then I can move all my numbers to one side. So subtract 2. And then finally divide by negative 11. So I get y equals positive 1. And remember, this isn't my answer, but it's part of my answer. So I have to find both an x value and a y value. So to do that, you can take this and plug it back into either of your original equations. Doesn't matter which one. I'm going to choose the first one. So I have x plus 4 times y, which is 1, equals 1. So now I have x plus 4 equals 1. And then if I subtract 4 from both sides, I end up with x equals a negative 3. So now I have all the pieces that I need to make my answer. I have an x part and a y part. So we write it in point form, and we're done. Let's skip this one. And the next one looks a little strange because both things are solved for y. When this happens, you are saying that y is the same thing as 5x plus 2, but it's also the same thing as 3x plus 6. So when I substitute this in for y, what we basically end up doing is saying that 5x plus 2 has to be the same as negative 3x plus 6. If they both equal the same thing, whether it's x or y, they have to equal each other. And then this turns into a quick equation that we can solve. We have x's on both sides and numbers on both sides. So pick a side that you want your x's. I'm going to put them over here on the left. And then pick a side that you want your numbers. So you get 8x equals 4. And then if I divide both sides by 8, I end up with x is 1/2. Now remember, that's not all of my answer. We need to find the y part also. Since we didn't do this one over here, let's move back over to the left. Remember, it does not matter what equation you plug it into. I'm going to pick the first one, again, just because it's first. But I have y equals 5 times 1/2 plus 2. And 5 times 1/2 is just 5 halves. And if I add 2 to that, 5 halves is the same thing as 2.5. So we end up with 4.5. So now I have enough information to make my answer. These two lines, if I were to graph them, would intersect at 1/2, comma, 4.5, which is the same thing as 9 halves. Next one is a little tricky because it's not easy to get either of those variables in either equation by themselves. So you're going to have to pick kind of the lesser of two evils. Whatever one you think is going to be easiest to get alone. So I'm going to go up to the top here. And in this first one, I have 3 halves x. If I want to get x by itself, I'm going to have to divide by 3 halves, which is not going to be fun. So definitely not doing that one. If I want to divide by 2 here to get y by itself, I would have to divide 3 halves by 2 and 11 by 2. Not going to be nice and pretty. So let's skip both of those. If I move down here to this 3x, I would have to divide everything by 3. Dividing by 3 is never a good idea because you end up with a repeating decimal. If I look here with the 4, I can divide 3 by 4. That gives me 0.75. And I can divide 16 by 4, and it actually gives me something nice and pretty. So even though there's not a wrong answer to which one we solve for, this is going to be our best option. So that's the one I'm going to choose. So we need to do that before we can do anything else. So let's solve for y in this equation. So we start with 3x plus 4y equals 16. Then I'm going to subtract 3x from both sides. And then I'm going to divide everything by 4. So we end up with y is the same thing as negative 3/4 x plus 4. So now that I know what y is, I need to do my substitution. Be careful that you do not substitute this back into the equation we just used. You have to substitute it in to the other equation for this to work. So I'm going to take what I know y equals, and everywhere up here, I'm going to replace this y with the other y. So everything stays the same. I still have 3/2 x plus 2, but this time instead of writing y, I'm going to write what y equals. Negative 3/4 x plus 4. And it still equals 11. So if we simplify to get rid of this parenthesis, if you do 2 times negative 3/4, if you type that in your calculator, it's going to spit out negative 3/2. There's still that x there. And then 2 times 4 is going to give us 8. And that equals 11. Now something magic happens here. 3/2 x minus 3/2 x goes away. This gives us 0. So we're left with a statement that says 8 equals 11. This is not a true statement. 8 can never equal 11. Ever, 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 no matter what we do. So when this happens, when we get a statement that's not true, think back to when we solved stuff. This means that there is no solutions. Which in a system means that these were parallel lines. These lines had the same slope. They will never ever cross, and that's why we have no solutions. Last one. Let's do the same thing with this. We have to decide what variable we want to get by itself first. And luckily, there's a y here that is almost all by itself. The only thing I would have to do is subtract 5/2 x from both sides. And when I do that, I end up with y equals 4 minus 5/2 x. So now I know what y equals, I can substitute it. And remember, you can't substitute it back into the equation we just messed with. You have to substitute it into your other equation. So everything else stays the same. We're still going to have 5x plus 2. But this time, instead of y, we're going to write what y equals. 4 minus 5/2 x. And then it still equals 8. So just like the last couple, we got to do some distribution. And if you do 2 times negative 5/2 x, you're just going to end up with negative 5x. And it equals 8. And again, something magical happened. 5x minus 5x goes away. And we're left with 8 equals 8. When you get something that is a true statement, this means this always works, no matter what I plug in for x or y. So that means that we have infinite solutions, just like when we were solving before. But in terms of our graph, this would mean that they were the same exact line. These two equations right here represent the same thing, they're just written differently. So hopefully substitution made sense. If not, again, there's 2 other videos that you can watch. There is a picture to kind of show you what's going on, and then you can play with the Khan Academy thing. Again, there's also homework that you can practice with.